So hello guys, we are going to discuss this problem today, word break 2. So this is lead code problem number 140 and problem says that we are given a string S and we are given a dictionary word dict. So we need to add spaces between the string S and construct a sequence of sentences in which the words exist in the word dict. So we have to return all such possible sentences, right? So whenever you find this term all possible sentences or all possible combinations or all possible arrangements or anything, right? So at that time I understand it as a backtracking problem because um, we will recursively reach every solution, but we will not ignore anything, right? Because we do not have we need to find the all possible things. Okay, so we are going to solve this problem with backtracking. So let's understand one example first. So we are given cat, sand, and dog, and the word dictionary is cat, cats, and sand, comma dog. So if we break this cat from somewhere here, this input word cat, so that will be there in the dictionary. So that's good. So then we'll break another word sand that's also there in the dictionary. Then we'll break another word dog. So the one sentence would be cat, sand, dog. This one. Then if we break cats, the cats is also there in the dictionary. Then we'll have and, it's also there, and then dog. So cats and dog is another sequence or another sentence. So we need to return all the possible uh, like sentences. So how we are going to do it? We are going to do with plain backtracking. In this video, we are not going to discuss anything about the dynamic programming or any other thing, only just plain backtracking. So how we are going to do it? So let me take this example. Pineapple, pine, apple, pen, apple, and the dictionary is this. Let me go to here. Okay, so our input is pineapple, pen, apple. Dictionary is apple, pen, uh, ap apple, pen, pine, and pineapple. So what are the possible sentences? So first is this one, pine, which exists here. Then we'll have apple, which exists here, this one. Then we have pen, which exists here, and then we have apple. So first is pineapple, pineapple that exists. Then we'll go with this one, that is pineapple. So pineapple also exists. Then pen differently exists and apple also exists. So pineapple, pineapple that also exists. Now we'll have pine exist and then apple pen, this one, this also exists, and then apple. So the third sequence is this. So now how we are going to do it with a backtracking approach. So these are the indexes of every character inside the word, inside the string. So first of all, what we'll do is we will find the substring starting from index 0. And whenever we find a substring which actually exists in the dictionary, we will note the position of the next letter and we will um, recursively jump to another backtracking function. For example, so first word is pineapple, pineapple. So we'll be finding the substring. So initially, let me just draw it here. So how we'll go? So we'll find first substring p doesn't exist. Then second substring pi doesn't exist. Pin doesn't exist. Pine exist. Yes. So pine exist, and the position will be 4 because we need to search from the next character. So we will create a word and we'll take a position and we'll jump to another backtracking function with position 4. So here equal to 4, sorry. So so in this backtracking function we will be traversing entire substring till 16. So and we'll try to find the word again. So now our substring is this. So now in this function we will again do the same, that is I equal to 4. We I equal to 4 plus 1, we didn't find anything. Then we go to AP, no, nothing, APP, nothing. Then we go to APL, nothing. Then apple, yes, that's found. So apple is found and APPLE. And the position which will be sent to the next backtracking function is 9. Something here, right? So we just jump to this function here. So This logic actually is there when we like fall back from the recursive function. We'll consider it later, but let's consider it for this. So we have the position 9 and word was apple here, right? So we are adding these words onto our string so that we can add those in the vector later. So we are at 9 now. Let me just take it again. So then again we'll search nothing. PE not pen. Yes, found. So from I equal to 9 to 16. So I equal to 9 to 16. We found a word pen, and the next position to search is 12. So we'll store it in string and we'll just pass on to our this function. So now we are at apple. So we will search from 12 to 16 and we found the word uh, 16 at the like the last word, and we will store the word and the position will be 16. That is the index to search from, the starting index to be searched in string in the next backtracking function is 16. And in the base case, what we'll have is if position is equal to size of the input string. So size of this input string is 16. In that case, we'll push into our out. So now in this case, pineapple, pen, apple will be pushed. Pine, apple, pen, and apple will be pushed into um, our output. Now we will fall back. So in this fallback, we were already at I equal to 16. So in this for loop, there is nothing to traverse. We'll come back here. Now in this for loop, we were at I equal to 12. So I equal to 12 was here, right? I equal to 12 was here. So now at I equal to 12, we have just jumped onto another backtrack function. So now we'll place A. So we were here, right? Let me just write it down. Okay. So now we will place A um, and search whether this exists in whether this exists in dictionary or not. No. So then we'll search. Then we'll make our substring as this one. That is we take one character more. This doesn't exist. This doesn't exist. This doesn't exist. Pineapple. Does this exist? This doesn't exist. So it will again come back, right? So nothing exists. Now we were at I equal to 8 apple, right? And we passed I equal to 9, that is I plus 1 to the next backtracking function. So we'll start from 9. So let me take this one here now. So we'll start from here. That is, we'll take this one app uh, apple p. So this doesn't exist. Then we'll take apple pe, doesn't exist. Then we'll take apple pen. Apple pen, yes, this exists. So what we'll do is we will pass I equal to 12. Sorry, this is I equal to 12 to our backtracking function. So position becomes I equal to 12 and I equal to 12 to 16 we'll search, right? And we'll find that apple is there. So what words so already one word was there, fine. Then another word was apple. Then another word was apple pen, right? And we inserted all these words into our output. So this apple, apple pen, and pine, these words we pushed into our uh, output, right? So this one. So basically, this is how when we will try to search one character, we'll try adding one character from the substring, from the main string into the substring, search into the dictionary while traversing back wherever we have left. Like for example, we have left here, we'll add one character again and we'll search every possible string into the dictionary, and if it is found, then we'll add into our output. But the on output is only added when the position becomes equal to size. So let's see the code for it. So this is the code. So initially, let me go on to, okay, so this is the code. So vector of, this is s is vector of string. I have taken it as like a type def, and then unordered set is just an ordered set of string. So initially all the dictionary is taken into the set. I have called it dict. Then I'm like we are creating a word uh, from 0 to I plus 1, and if word is found in the set, we are just calling the backtracking function with position I plus 1. Now in the backtracking function, this is our base case. That is when position is equal to the size of this input string, which is something as pineapple, uh, pineapple. Then in that case, we are pushing it onto our val. So val is a vector of string. But if it is not, then we are traversing from position. That is, if we are at this position, that is a position, then we'll be traversing from here till size, and we are finding a word that is from this one. We are going to search something like this, and if that word is found, then again we are going to call the backtracking function. In backtracking function, we are just going to add um, the word which we found recently into the string, and then we are again going to call the bt function. So I have already discussed one in one of my video as the backtracking template. So in backtracking template, what we have is we have a recursive backtrack function, we have a base case, and we have to iterate through the candidate list. Let me just, okay. So we have to iterate through the candidate list. Okay, here. So in this case also we are iterating through all the candidate list. So these are the candidates we are creating word, and if candidate is found, that is it's a valid candidate, then we are placing this candidate. That is, we are placing this candidate onto our ST. So this is placement of the candidate, and finally we are removing the candidate. So now in our case, since we are incrementing the position, that is once we as we have already seen that once we are at 12, then we are incrementing or taking the next candidates. So this is equivalent to removing of the candidate. So in the backtracking template, we have last step as remove the candidate. So this is basically very same as a backtracking template. So that's all for this video. Thanks a lot. Have a good day.